Now we suppose we know that x star is the local minimizer of the function f over the region omega. And we know that the region omega is a subset of the set omega prime. So the first question asks, if x star is the interior point of omega, then x star must be a local minimizer of f over the larger set omega prime as well. Okay, let's see what that is. So from the figure, you can see that this is omega. Okay, and the larger one is omega prime. So now if x star, which is this point here, is an interior point, is a local minimizer of f over the omega, and also it is the interior point of omega, that means we can find this neighborhood of x star here, so that this neighborhood completely falls inside the omega, because this point x star is the interior point. At the same time, because x star is the local minimum of f, so we can also find, so this is x star, we can also find the neighborhood of x star such that f of x star, it takes the smallest value in the neighborhood. So we can take the smaller one of this neighborhood and the one here, so we can just get this neighborhood of x star, so that not only that it is falling into the omega, but also this x star takes the smallest function value among all the other points in this neighborhood. Okay, so now you can see that if I enlarge this omega to omega prime, this is still completely inside the omega prime, because it is completely inside the omega. So that means x star is the interior point. And also x star is takes the smallest function value in its neighborhood. So that means x star is still a local minimum of f. Okay, and this implies that x star is also a local minimizer of f over the larger set omega prime. So the second question says that can we claim the same thing without assuming that x star is an interior point? So if x star is not an interior point of the omega, then we cannot make the same claim as before. So in this case, let's think about a simple example. Suppose we have this function f that is just simply x. And then the omega is all the positive part, including the 0. And the omega prime is the whole real line. So now you can see that if I just look at my function f, I restrict my function f to omega, then the smallest value of f is right here at the origin, at the 0. Okay, so that means x is a local minimizer of f. 0 is a local minimizer of f because it takes the smallest value. But this x is not the interior point of the omega because it's on the boundary of omega. Okay? But if you look at this look at this 0 over the omega prime, which is the entire line, then you can see this point is not a local minimizer anymore, because there will be points on its left which take smaller value than itself. Okay, so in this case, if x star is not an interior point of omega, then being an interior point, being a local minimum of f over omega doesn't guarantee that it is also a local minimum of f over the omega prime.